Alright everybody, what is up? This is the Odd Programmer and today we'll continue our MVVM tutorial series. In the previous video we looked at how to set up view model for our restaurant simulator application. So we have our room database set up, we have our view model set up. Now the only thing left is to connect the view model to the view. In our case we will show the list of orders in a recycler view. So we will look at how to set up data binding in recycler view adapter. Next we will look at how to set up view model in our activity. To make sure everyone's on the same ground till this part of the tutorial, check out the restaurant simulators view model branch on GitHub repository. Link will be given in the description. So let's get started. First of all, we'll set up our layout to use data binding. To do that, first open this order item layout file. By the way, this is the layout for our recycler view items. Now wrap this whole layout inside this layout tag, as you can see I have done here. It is necessary to do this for data binding to work. Inside this layout tag, first insert a data tag. Now inside data tag we will declare our variables which will be used in the views. After this data tag, there should be the view tag which is the root of this layout, which means that after data tag there should be the normal layout structure which would have existed without this data binding stuff. Okay, so in our case we have to define an order variable which will be used in the recycler views adapter to show the corresponding order item. So we have it defined here under this variable tag. First attribute is name, which will be used as the name of this variable. In our case it is simply order. Next property is type property, which is used to define the type of this variable. In our case we have it defined as the order entity we have created earlier in the room components. Now we are done with the data part. Next we have to set up the binding expression in the view part. Binding expressions are written within the layout in the attributes properties using @ braces syntax. These expressions are written in the expression language. So that means we can have operators too. Logical operator, unary operator, comparison, etc. can be done inside. Okay, in our case, first text view is used to display the order name. So we have set Android text attribute to use the item property of the order object. As you can see I have done here. Same thing is done with the next two text views, used to display the order amount and order instructions respectively. Next, open the layout for main activity and add this attribute here. This list item attribute is used to set the layout for the items of the recycler view. So that's it for the layout files. Next we'll create an adapter for our recycler view. So go ahead, right click and add a new package and name it adapter as I have it here. Under adapter, create a new Kotlin class and name it order adapter. Now time to edit this adapter class. First of all, make this class extend recyclerView.adapter class as I have done here. Make an internal constructor for this class and take in a context as input parameter. This context will be used for the layout inflator. Next we have two private fields. First is the layout inflator, second is the list of order which will be displayed in the recycler view. As you can see, list is initialized to an empty list. We will have a public method to set the list via view model. Okay, next is the inner view holder class. Name it order view holder and make it extend recycler view.viewHolder. Next, create a constructor for our order view holder class and take a binding variable and set it to a private field. Okay, so the binding variable is of type order item binding and you must be wondering what is it. So if you remember, we named our layout file for the recycler view item as order item.xml and we have already modified the layout file to use data binding. So the data binding library automatically generates this order item binding class to use for data binding. Naming convention is simple. Name of the layout file is used in Pascal case and the term binding is postfixed. So in our case, the layout file is order item, so it gets converted into order item binding. Now coming back to adapter class, this recycler view.viewHolder class takes in a view for initialization. So we are passing the binding.root, which refers to the root view of the layout file. Next, we have a method bind, which takes in an order and set it to the order field of the binding object. Next, we call the execute pending bindings method of the binding object. What this method does is that it commits any binding which is pending, and in course it will update any view which has expression bound to modified variable. It simply means that it will update text views in our layout file which uses binding expression to show the text. Next, we have these two override functions. First one is onCreateViewHolder, in which we are creating an order item binding variable. This inflateStatic method is used to inflate the layout and return the binding object for that layout. Next, we are returning the view holder. Second override function is onBindViewHolder. We are getting the current order from the list of order and then bind it to the view holder. Last override method is this getItemCount, which returns the total size of the list. Last method is this setOrders method, which takes in the list of order and set it to the private field of this adapter class, and then call the notifiedDataSetChanged to notify the adapter of the change in the list of orders. So that's it for our adapter class. Next, we will modify our main activity class to set the adapter to the recycler view and get data via viewModel. So edit the main activity class. First, add these three private fields: order viewModel, order adapter, and activity main binding. The last one is the binding class automatically generated by the data binding library. Okay, next thing to do is to inflate the layout. So in onCreate function, right after calling super.onCreate, we normally do a setContentView, but as we are using data binding, we will use the binding class to do the same. Next, we are initializing our adapter. After that, we are getting the instance of our viewModel that we created earlier. We are using the viewModel provider class to get the instance. Next thing is to register our main activity to observe the live data of list of order, which is returned by the viewModel. Live data is an observable data class. So to do that, we are calling this viewModel.allOrders method, which will return the live data of list of orders, and then we are calling observe on that. We are passing in the main activity as the observer, and next is an observer instance, which is a fallback which receives the changes from the live data. Next thing is the Kotlin extension function let on the list of orders object, which is delivered by the live data. We are checking if it is empty or not. If it is empty, we are setting text be visible, else it is gone. Next, we pass the list of orders to the adapter's setOrders method that we created earlier. This will set the list of orders returned by the live data to the adapter. If any changes occurs in the list of orders, live data will notify its active subscriber of that change. In our case, it will notify the main activity, and as defined in the observer callback, it will set the new list of orders to the adapter. It's pretty simple and useful, isn't it? Okay, next we have this setup views function, which is setting our on-click listeners. First one is for the create order button, which will open new activity for order creation. As we are expecting some data to be returned from that activity, That is why we are calling the start activity for result function. Second, we have the on-click listener for clear button, which will be used to clear all the orders stored. So we are calling view models delete method. Next, we have recycler view instance. We set up the adapter to it. We set up the linear layout manager and add the item divider. Finally, we are overriding the onActivity result function to insert the order in the database via view model. We get the bundle returned from the create order activity and then create a new order from the data returned. Now, there are two things to notice. First is that we are passing 0 in place of ID field. Since we have already defined it as AutoGenerate is equal to true in the entity class, we have to flag this field as not set when inserting the order object. Now, according to the developer's website, insert method treats 0 as not set while inserting the object, but in the case of this primitive type only, and in case of non-primitive type, it treats null as not set. Now in Java, it is pretty obvious that whether the type is primitive or not. Primitive type starts with a lowercase, for example int, long, etc. And non-primitive type or object type starts with an uppercase alphabet. But in Kotlin the problem arises because in Kotlin every type is non-primitive by default. So int and long are classes and not primitive data types. Then we should use null every time, right? Wrong. Kotlin's non-nullable int is translated to Java's primitive int, and Kotlin's nullable int, the one which ends with a question mark, is translated to Java's non-primitive integer. That is why we are using 0. Second thing to notice here is this not null operator, the double exclamation mark. It is used to convert a nullable type to a non-null type. We are using this because we are making sure that the data returned by the activity is not null. We'll see that in a minute. Last, we are inserting the newly created order item into table via view model. So that's it for this main activity class. Next we will edit new order activity class. In our implementation, we are first checking if the edit texts are empty or not. If any of the field is empty, then we show error. Otherwise, we put the data in a bundle and return that bundle to the calling activity and then finish the current activity. That's how we are making sure that the data returned is not null and it is safe to use that not null operator in main activity class. Okay, so go ahead and compile and run the application. Finally, you have made an application which is based on MVVM pattern using Android Jetpack libraries, which is totally awesome. To take reference, just head over to the GitHub repository and check out the data binding branch. Link will be given in description as usual. So that's it for this tutorial series. Good luck and don't forget to like, subscribe and all that good stuff. This is the Odd Programmer. Peace out.